Hello 8th grade, I am Mr. Rogers and you are watching the video notes for section 1-3 in our book, and these are on controlling chemical reactions. So this first page you do not have to write anything down. This is what we hope to learn, be able to explain why activation energy starts a reaction and list and understand factors that affect the rate of a chemical reaction. So there are two kind of major classifications of reactions. We've talked about how we know a reaction is taking place and things like that. But an exothermic reaction releases energy in the form of heat during reaction. So when you burn wood, it releases energy. You can feel the heat. Then we also have what's called an endothermic reaction, and they absorb energy. Usually will feel cooler during a chemical reaction. That instant cold pack where you pop the middle and you shake it up and now it's cold, that'd be an endothermic reaction. And so the other kind of key term that we use a lot is activation energy. And so this is the minimum amount of energy needed to start a reaction. So a piece of wood, you've got to add heat to it. You need so much energy for the reaction to start to burn. So activation energy is that amount of energy needed for it to start. And depending on the types of substances, depends on the amount of energy needed for that reaction to take place. So we're going to focus on here is how can we control a chemical reaction? How can we make it happen faster, slower, or why do things kind of fizzle out after a while? So the rate of a chemical reaction is affected by factors like concentration, surface area, temperature, and by using a catalyst and inhibitor. So in chemistry, guys, we use the term concentration. So the concentration is the amount of one material in a given volume of another. So a good example would be your sugar in lemonade. Take that sip of lemonade, you're like, oh, this tastes just like water. So there's not enough sugar and there's a low concentration of sugar, maybe lemon flavoring, lemonade, in your lemonade. So if you have too much sugar, you're like, oh man, it's like pure, I took a sip, it's pure sugar. Now it's the opposite. Now you've got a higher concentration. So that's the idea of concentration, the amount of one substance in another. A lot of times how much of one thing is dissolved in another, like water. We can also do things like add a catalyst. A catalyst is a material that speeds up the rate of a chemical reaction by kind of lowering that activation energy. So less energy is needed to start that reaction. And we also have what are called inhibitors. So a catalyst speeds up. Inhibitors do the opposite. They slow it down, chemical reaction. And along with a catalyst, we have what are called enzymes. And enzymes are just biological catalysts. They're found in living things. So you have hundreds of enzymes inside of you working all the time to keep reactions happening fast enough so you can stay alive. So we look at this, guys. You'll see these two charts in our notes here. And then also I want you to put these charts in your notes. So there it is. When I check your notes in class, I better see these two graphs. So on here, guys, we have one for an exothermic reaction. That's releasing energy. It's giving off heat. And the way to look at this is we have the reaction progress. That'd be like time on your x-axis, and your y-axis, we have the potential energy of it. So here's our reactants. And when that energy is added, so we get that piece of paper heated up enough, like under a flame, and the reaction starts, and it gives off all that heat. And our products, you see that energy is being released there, are going to have less energy. So the way you look at that graph is it starts with more energy, it gives it off in the form of heat, and now it has less. For an endothermic reaction, it's going to be a little bit different. Now we're absorbing energy, so it feels colder. So here's that time. There's the amount of energy. So down here now are the reactants. The energy is needed to get started. Now it's going to be absorbing energy. You can see here the absorbing energy. So our products have more potential energy than our reactants because it's taken in. It's kind of pulled energy in from around it, so it feels colder to the touch. So the other thing I want you to look at real quick here is the idea of a catalyst and how that works inside of your body. So when reactions happen, you have molecules kind of bumping into each other, and they got to kind of lock into each other for the reaction to take place. And what a catalyst does, you can see it here in green, like an enzyme. They give a place for the reaction to happen. So they want to kind of bump into each other, but need to be in the right place. So a catalyst gives a place for the reaction to happen. So on the other side, an inhibitor might actually kind of stop it. So here's like a inhibitor bonds to a catalyst. So now the two that need to get in there can't get into the green molecule, and now it stops that reaction from happening or slows it down. So a catalyst is going to speed it up, give it a place to react. An inhibitor might do the opposite, where it's going to slow it down by blocking those reactants from interacting with each other. So 8th grade, that's all for today. We're going to stop right there. Thank you guys for watching, and we'll see you along the way.